Hi guys, welcome to Springboot Complete Learning Course Part 3. Thank you for watching Part 1 and Part 2. If you are not watching Part 1 and Part 2, please watch Part 1 and Part 2. We are going to learn some advanced feature in Springboot in Part 3. Thank you for watching. Let us get into the session. Hi guys, we are going to discuss today what is cache and how the base cache is integrated with the Spring Boot 3.2 version, and how to build a Kafka producer microservice, and how to build a Kafka consumer microservice, and how the producer microservice are sending the data to consumer microservices using a SSL. Right, so these things we are going to discuss today. So first I'm going to discuss what is cache. Cache is the middle layer which can cache the data. Let's say cache can be used in various layers. Database layer we can use, business layer we can use, presentation layer we can use. So multiple layers we can use based on our use cases. But let's say we are going to read the data from database frequently, but there is no write access, or the frequency is very less for write operations. So when you are reading the data is every time, let's say I'm going to consumer microservice is calling producer, and producer is calling the database and then fetching the information. So a lot of network round trip, and it has to fetch the database. So all those things can be reduced when you're using the cache, right? So we will check if cache the data is there. Otherwise we will just read the data first time and keep it in the cache. Okay, after that we will not call the database or producer microservice every time, right? So this will reduce the network latency, and so we can read the data in the faster way, right? So that's how we are using cache, right? So cache major use cases is when we are reading the data frequently, but the write operation is very less, and we are using multiple configuration like cache expiration. We can keep 1 day or 2 day or 5 day based on our use cases. And whenever we are updating the data, update operation happen, we have to remove the cache item or invalidate the cache. So those things we have to taken care as part of our use cases, right? So now I'm going to discuss about Couchbase cache. Couchbase cache is one of the open source cache. It's a popular cache, NoSQL database, which can be used to cache the item, and then we can retrieve that, right? So this Couchbase cache we are going to integrate with the Spring Boot 3.2 version. Okay, let us get into the demo. I'm going to create a project called let's say I'm going to create Couchbase, right? I'm going to add a web module, and then Couchbase data. But I have already noted the required dependency. We can add it. Just for now I'm added. We can remove this one. We add only Spring Web, and then I'm going to Couchbase. Here also I'm adding Couchbase. Here Couchbase dot cloud4, and here also Couchbase cloud4 I'm adding Couchbase. I'm adding here also. Okay, now I'm just generating the project. This is the usual steps which we need to follow, that, right? We are coming and then extracting the zip file and writing into the folder. So these things are remain same. There is no change in this part. Just I'm going to extract that. So this Couchbase we are going to use a cloud-based cloud hosted Couchbase, right? We are going to use that, and I'm just going to import that. How the Spring Boot is integrating the Couchbase, right? I'm going to import that C drive and Spring Boot complete course. I'm going to import Couchbase. Yeah, now Couchbase is imported. I'm going to change the Couchbase microservice. I'm going to add port number server dot port equal to 8084, let's say. Okay, I keep that, and we can configure the username, password and URL in the URL itself, or we can create a configuration class where we can keep it. Normally we need to keep it in the property file, and then that is a best practice. Since it's a demo, I'm just using directly I'm going to use the configuration class. I'm creating configuration class. First config folder, config, create the config. So here I have already noted what is the name of the class. I have already noted. Let's say yeah, I'm going to create Couchbase configuration class. So this is, I'm just name it Couchbase configuration. You can add configuration. This is a configuration we are going to host it. That's the reason we are using configuration, and then we need to use this class. So we are going to use Couchbase template. So we can keep the cache in multiple ways. Annotation based cache, I will tell you that, but I'm using this way because if you are using annotation, right, sometimes when you are writing more business logic without annotation, it will, entire class will be tagged, entire method. Instead of that, this Couchbase template we can use. This is a best practice. Couchbase template we can use. Before going to that, I will add a dependency. So dependency are not added, right? So these are the dependency we are going to add. These are the dependency I'm going to add. Test, we can remove it. Just adding. If you see this Java here, Springboot couch data, this is the dependency, and here we are exclude the inbuilt Java version. That's why exclusion I'm doing, and then we are adding the Java Couchbase client. So this client we have integrated. So the required dependency, these two are the major dependency for integrating Couchbase with the Springboot. And Lambo is basically generating the getter setters automatically, so we don't need to write in our business class, in our value object. We just value class, we just add only member variables, no need to add any getter setter. That's the reason we are using Lambo, as I explained in the previous session. Right, now I'm going to Couchbase. See, Couchbase, I'm just a configuration, right? Couchbase configuration, and just remove all these things. Configuration is not unwanted. So I'm going to this dependency Couchbase, I'm going to integrate it. Configuration tag and bean tag I'm adding. So Couchbase template is you can use in the best way, whenever we have code is there and we want to use inside the method, we can directly call this Couchbase and then we can use it. Okay, so I think this I have to integrate. Couchbase factory class, authenticator, and then simple factory. These many errors are coming. Okay, password authenticator, Couchbase, we have to use Couchbase. Simple connection factory, connection string, this. Okay, so this, what is the error you will see? Mapping converter is that. Yeah, now we imported all the classes, and now our Couchbase configuration is ready. See, this is a bucket name. I will tell you how when you are creating the Couchbase, we have to create a bucket. This is a bucket name. The bucket, all the data are stored. Okay, bucket name, and we are calling this method bucket name, and then credential, we have to create authentication. This is the user ID and password of the Couchbase, right? This is a Couchbase URL. Load hosted Couchbase URL. These things you can find it in the, when creating the account in Couchbase cloud hosted, you can get the URL and then password and bucket name, everything we need to create, an authenticator bucket name. So this is the configuration, required configuration for connecting the Couchbase cache, right? It's a NoSQL database, you have to connect that. right? This is a configuration. And pom.xml, as I already mentioned, these are the major dependency we have to add. Data couch base or Java client. Okay, once we did that, then we have to go here. Once again, I just remove the test class because test class is not required, so I just remove the test. Yeah, I'm creating a controller. I'm going to create a controller folder. First I create controller I create a controller. So here I am just saying couch base cloud for academy controller, creating the controller, and then annotation rest controller, and then the controller we are going to add this method. What are the methods we have to add? See, I am just going to add couch base auto configure. First we have to auto this couch base configuration because we are going to use that, right? It could be in the business layer, but I am just writing, since it's a demo, I am just writing directly here. Okay, and couch base configuration, I write that, right? Okay, then we have to write this the methods. We can write these three methods. We can write it, these three methods. First method, I am going to elaborate this first method. Get mapping is a REST mapping, couch base cache test, or put. We can put couch base cache put, and same name we can put here. Put couch base cache put method. You can say put method, and you can remove this commanded code and all. So I'm going to use the business business object. This should be normally a database, but since we are not using database, I'm just creating a business class, one value object. Let's say I'm going to business object. I'm creating, name it called class called, let's say customer. I created a customer. Okay, here we are going to use a Lambo, right? We don't want to getter setter. We don't want the getter setter, so I am using Lambo. Getter setter we don't want. I am using Lambo. Creating a private string customer ID, private string customer name, and private string address, customer address. I just creating these three properties. Importing, you have to import that, right? Once we imported, now we are going here, Cloud for Academy. I'm going to create a customer object. Normally just for testing I'm creating, hard coding this. Actually it should be a database object or some it will come from database. So we are just caching. I'm just hard coding the data, like Cloud4 ID, and then Bangalore, name is Bangalore, and then I'm creating customer ID record number 2, creating Chennai, and then customer ID Odisha, and then customer ID Delhi, and then customer ID here also ready. So I added Mumbai. So I added 5 data. I added these 5 data. I'm going to cache it, right? I'm going to create these 4 hard-coded customer object, like Cloud 1, 2, 1, 2, 3, Cloud 4, 3, 3, Cloud 4, 4, 4, RU11, 1, 2, 3. So we are using different naming and just number and different location. And then I'm going to add couch base configuration. This configuration class. Okay, this configuration class is already auto-wired. Dot couch base template method. This is a method. Couch base template method. This method we are calling. Dot. This is called upsert method. Upsert method means it is going to keep the value into the cache. Which cache is going to customer class. Class name is, and the object is customer object. So we have to give customer. This is the way we have to write a value into the cache. We can put the value into the cache upsert method using couch paste template. This template is Springboot is provided. We can use that, right? And then like that, I'm copying, keeping all this data into the cache. Now customer one only I kept it. Now we will key customer 1 and customer 2 and customer 3 and customer 4, right? So all the data we kept it. Now couch paste cache test retry couch paste cache retrieval cache id we are giving, right? So this is the cache id. So now I kept cache 1 and customer 2, customer 3, customer 4. All these object I kept it in the cache, right? Couch paste cache. I'm just going to retry how we can retry the cache. See, I'm just writing another REST called REST method. Cache id. If you pass the cache id, it will what it will know. It will return. It will go there and it will fetch the. Sorry, it will go here and path variable also enable. And what it will know, it will go to book customer, right? Couch paste, first what it will know, it will check whether this couch paste cache is exist or not. So first cache, this value is cache id. Cache id means it's nothing but customer id. This customer id is exist or not. These are the customer id, right? If it is, otherwise it will throw the error. That's why we are checking the cache exist by id method. If the method is exist, then what it will know, it will come here and cache find by id, and then it will go there. Customer class dot cache id. It will give the customer. This is find by method we need to use to retrieve the value from the cache. So once you retrieved, so I can remove the logs not required. So just I am using file logger. Logger also is not required because we are using REST API, right? This will return that. This is a cache evict. Like that, cache put we can use. So these are the annotation. We can annotation based we can write the cache, but this is all some use cases we can use it if it is simple method and we can write it. But now I'm not using that. I'm using, instead of that, I'm using couch paste template, right? Now what I'm going to do is I'm going to start the servers, right? So now we have configured the cache, couch paste cache we have configured. Now I'm going to start the object. I'm going to run the application. So I'm just running the application. So this is the way we have to keep the cache and retrieve the cache. And cache we can two way we can annotate it. There is an error is coming. Couch paste configuration bean type considering some error. What is the error? Failed couch paste configuration accordingly record could not be found. Okay, so couch paste auto add, maybe enable cache. Let's say enable cache. Enable caching. Let's try that. Because of that this error is coming, or what is the error? We need to see what is the exact dependency. Starting the server again, we will see any errors are coming or not. Okay, again it's coming. Auto record to dash 2. The as of injection as a following annotation required to auto add couch paste configuration. It could not be found. Controller required. It's not required. So here is the problem. Let's say member private couch paste configuration. Let us see what will happen. So still there is error config in the configuration. So hi guys, the issue is identified because the couch paste cache name is out of the box already, name is there. So I just rename it to Cloud4 couch paste configuration. So after that the error is resolved. The same pin is annotated and then this things needs to done. And so now this error couch paste template, right? This template we have to use and instantiate with the factory class and then converter. The factory class has to pass the bucket name, and the bucket name it has to go here. From there we have to instantiate that. We have to get a credential, user ID, password, and then we have to create simple client based factory, couch based client factory, which has to pass the cloud hosted Couchbase URL, host name, and then user ID password as authenticated, and then bucket name. So now our connection is ready. I am going to start the server. I am going to start the server now. Yeah, I'm going to start the server now. I don't think so. Now it won't be an issue. So now the Couchbase is connected. See, Couchbase is connected. Couchbase, it is saying clearly saying that you can see Couchbase transaction successfully initiated. Couchbase database is connected successfully. So this is a cloud hosted Couchbase is connected. So this is a controller. As I said, I am passing these five hard coded values, keep it in the cache, right? And then I am calling this method, which it will retrieve this cache value. So first REST service is going here and 8084, and I am calling this. It is calling, sorry, what is the port number? Port number is exception. There is one exception is coming. ID properties needed. Yeah, so these are the classes. I'm going to execute that. I'm getting error. So we'll see what is the error. ID properties needed but not found could not be generated in this entity. ID property is not there. That's what it is saying. ID. Okay, sorry. Here we have to use ID, not customer ID. Should be ID, right? Should be ID. So now I'm going to stop the server. I am not using dev tools. That's why I'm starting every time. So I'm just going to start that. Okay. I think now it started. It will work now. So now I'm going to cache this item. This item I'm going to cache this. Okay, cache this. I'm just hitting. Yeah, now it's cached. The items are cached. So now I'm going to access this URL. The cache ID I'm going to pass cloud 411. Let's say cloud 4111. Entering. See, one record is cached. So if I hit 222, it will be 22 Bangalore, Chennai. So this is the way we have to retrieve the item from the cache. If I see some other value, it will not come. See, no value is coming. So I'm going to log in Couchbase cloud hosted. See, I'm going to log in. If I log in that, we can see the data are stored or not. We can see. So this is a database I created, and then I'm going here. I'm going data. So now I'm just going documentation, get all documentation. How many documents are there? You can see 10 documents are there in the bucket. So if let's say I'm going to give something like cloud, I'm searching with ID like cloud 4 to 2222. It is coming. See, one record is finding record, but we are not able to see the clear view because it's a free version we are using. Let's say I'm just typing some other value. See, yeah, document ID not found. That's how we have to verify. If I put, it's a cached item value is there. See, if I give some other value, see, document ID is not found, right? So this is the way. This is our database name. Bucket name is we can see which is our bucket. So this is the bucket. Provision and export the data. So we can see where is a bucket. We can see the bucket as well. Cloud 4 and then bucket query. We can see the bucket as well, but I couldn't now see that. Provision data search. So we can see the bucket name as well. We can create this way. Database and then bucket name. So this is a way we have to create an account and then have to create a database and then bucket name. Bucket name I couldn't see. Cloud 4. Cloud 4 is the database name, and inside we can see the we will see the bucket name. The bucket name is, we can see Cloud 4 Academy. Yeah, here we can see data tools. Cloud 4 Academy is the bucket name, right? Cloud 4 Academy is the bucket name. So this is the way we have to create the we can query and everything we can do in Cloud 4 in Couchbase. We get set. This is the bucket name, we can see that this is a bucket name. So this is the way we have to verify. And so it will try the cache value, right? Suppose if I stop the server, let's say I'm going to stop the server and restart again. I'm not going to keep anything, I'm just going to fire this cache retrieval only. So cache is annotated, and now I'm going to hit this, let's say 444. See, Delhi, it is coming the data, right? So I didn't put the data, but it's reading the data. So this is how we have to integrate the Couchbase cloud hosted cache with our Springboot 3.2 version. The first configuration is pom.xml. Pom.xml, the version is Spring version is 3.2, and then dependency, just you can check, these are the major dependency we have to add it. Spring data Couchbase, and exclude the JDBC from that, and then add the separate dependency Java client, Couchbase client. So these dependency is required, and then property file, nothing is required, you can leave it. And then Couchbase configuration, this is important. Create a configuration, bucket name, here the bucket name, Couchbase template, and then give the Couchbase host name, and then user ID password. This is the way we have to connect the Couchbase. Once you connected, these are the custom logic, right? Your business object, and then go to controller, and we are just writing that and how to keep the data into the Couchbase, and then how to read the data into the Couchbase. This is the way to read the data from Couchbase. This is checking first the ID is there or not, then we are reading that, otherwise it will throw the error. If item is not there, it will break that, right? So this is the way we need to integrate the Couchbase cache with Springboot 3.2 version. Thank you guys. So let's get into next session is Kafka consumer and producer setup. Hi guys, we are going to discuss about these are the topics, how to create a Docker image, and then how to push and pull the image from Docker Hub, and then how to deploying the images into Kubernetes cluster in Minikube. Minikube is a single cluster node in local, and then consumer microservice we deployed, and producer microservice we deployed in the Minikube, and then we will make a connection between the consumer and producer microservice without using local IP address, right? So using service discovery, that is called service discovery. So we will be using Kubernetes discovery, service discovery, we will be using that, right? So first we will discuss what is Docker. Docker is container, right? Docker is used to create a static image, which then it will launch create a multiple containers. So now Docker actually in monolithic architecture, I mean 10 years back in monolithic architecture, what used to do, if you want to install Oracle software, Oracle database, or any messaging system or a search engine, anything, if you want to configure the application, we need to download the exe, and we need to install, and we need to configure all the properties, and then based on our application changes we have to configure it. So this is the really headache, right? So if 10 users are there, let's say one team where 20 or 30 people are there, all 30 people will needs to install the same configuration, and also if you want to go to the QA environment, production environment, or staging environment, they have to install separately, separate configuration. This is really hectic, right? So in microservice architecture, they introduce a Docker. Docker is a container. Docker is nothing but is creating the container. So containerization. So like Docker, container D, there are multiple containerizations of tool is there. So Docker is a popular tool, containerization tool, and so Docker, what you will know, Docker will create an image. Let's say if you want to deploy a microservice, it will go to create a static image and push it into the Docker Hub. Docker Hub is a Docker registry, it's a centralized registry where we can deploy all our images, and then we can download when we are going to deploy into the Kubernetes in the cluster environment, right? So that is what Docker Hub we are using. And then Kubernetes nothing but a cluster environment. We can set up the cluster nodes, and then we on top of it we can launch multiple pods. Every pod will launch the container, right? So let's say same container, multiple pods can use the same container, or different containers, different pods will be running. So this is all based on the configuration, right? And the third thing is we will deploy this consumer microservice and producer microservice in Minikube using Kubernetes, and then we are based on the service discovery, we will be using service discovery, we will be connecting, consumer will be connecting to producer microservice without using IP address. So because we are using service discovery we can help us to achieve the load balancing and fault tolerance kind of things, right? So that's what we are using in the microservice architecture, right? So Docker is mainly used for shipping the image, actually shipping the all the dependency it is shipping, and then it will be shipping, right? So Docker is shipped all the dependencies in a single image. Wherever we need, just we can run the as a Docker file or Docker Compose. Docker Compose is a multiple images or layering. So Docker file, we can just install that, and on top of it we can layering, we can set up the environment variable, all those things we can do. That is called Docker, right? And we can how to create a Docker image. So we are to using a Docker file, we have to create a Docker image. So various layering we can set up, and then creating the static image, and then we can launching in the Docker container, that becomes a container. So we can launch multiple containers, right? So let us get into how to create a Docker file, how to build the Docker file, and then creating the Springboot microservice, and creating the Docker creating the image using Docker file, right? Let's get into the demo. Hi guys, getting to the demo. In order to execute a Docker file, we need to build a application. We need to pack the application. If you want to, let's say consumer microservice, we want to create an image, we need to build that jar file we have to create, right? So that's what Maven we are using, right? Build tool. So we have to go to pom.xml and right click and run as Maven build. We have to go to pom.xml, right click and run as Maven build. Here we have to package, we have to give package goal run. It will start building the compile the code and then package the jar file, right? So that's what it is doing now. So we can see here it's building. Build success, create a jar. Now build is success. Now if we go to target directory, the jar file will be created. I just refresh that. So see, this is a jar file, consumer-001. It's a jar file which was created, right? So in order to run the Docker, we need to install a Docker. To install a Docker, we have to install into the Windows, right? Since I'm using Windows machine, like install Docker on Windows. If you give that, I think this link, install Docker. Here you can see install Docker desktop on Windows, system requirements, come down, scroll down on the install Docker on desktop, and VM we have to select. Either VM has to be like we can create a virtual machine, Docker itself. These are the steps we need to follow and create it. Once we install it, what we can do is we have to go to, like I have already installed, so the Docker desktop is appearing, run as administrator. So Docker will start, and we'll see Docker is starting. Once Docker is started, we can see the logo here. Actually we can see the logo like this way, like you see here, see this is a logo. Now Docker is running. See, this is a logo, Docker is running, right? So this icon will show like Docker is running, right? Now Docker is running. So to create a Docker file, we can go to Visual Studio. I think already I open Visual Studio. You can install the Visual Studio. Let's say I'll close this. So we have to create Docker file. So D should be caps, and then all are small letter, Docker file. It should be naming convention. That should be very exactly, it should be like this, Docker file. That's it. So if you enter that, it will create a Docker file. Let's say I'm going to create in desktop. So Docker file is created, right? So this is the way the file name should be, Docker file, and then these are the Docker commands. So from this is a base image. This is a base image which we can public image. We can download from there. From there we can build our image, microservice image. This is a Java version 17 base image. So it's provided the Java runtime environment, and then we can execute our microservice in any of the environment, right? So we build a jar file. So create a jar file. We need to know the jar file name. This is a jar file name, right? Consumer jar. and I'm copying this jar file name. This is a jar file name. We have to give the jar file name, right? Consumer jar. Here I'm giving Cloud 4 Academy. Cloud 4 Academy test. I'm just giving any name we can give. And so these are the couple of comments, are the Docker comments we can give from volume org add and then entry point. So these are the steps like add a jar file into the class path and then running that. So these are the things we will be using that, and these jars are running. So and the temp directory it will be stored. There are a couple of Docker commands we can discuss when we are the session, when we are taking the Docker session, right? Docker session, right? And once we done that, and we can create a Docker Hub account, so that we can create a pushing the image and pulling the image, right? Docker Hub login. If you give Docker Hub login, we can go to login. Docker Hub registry. We need to register our user. Since already I have logged in, I log out, and if I want to sign up, new user, you have to sign up. Since I have already account, you can say to gmail.com. I'm just login. So I have so once we created a Docker Hub registry, we have to create a Docker ID. Docker ID is nothing but you can see this is a Docker ID. These images are already there, right? Kafka, you can see, should start like Docker ID slash and then image name and colon version number. Let's say whenever we are changing the code changes, we need to rebuild the image, right? So we are giving version number colon v1, v2, v3 like that, right? So this is what we need to give. So we have to push the image. Once we push the image, this is the public registry where we can see our all images. See consumer app, consumer microservice. All these images I already published 21 days back. If you want any community images or public images, we can make it private images, so it can be accessible only by the particular organization or particular user. So we can make it private or public. So this is what is saying accessibility. Public image means anybody can access it, right? So this is what we have to pushing and pulling the images. So if I go to here, we can check the see version v5 v2. If I click v5 version, so this is the image name, full image name. You can see this slash consumer -micro colon v1, right? So this is what we have to naming the image. Now I'm going to create a image using Docker, right? For that, what we need to do is I'm just going to the Eclipse. I'm taking the path because we need to host that Docker file. Docker file we can keep anywhere in our code base. Let's say where is the Docker file? Yeah, this is the Docker file, right? We can host anywhere. I'm keeping in the inside the target directory. Yeah, target directory. I'm going to take this path. I'm going to take this path, and then I am going to command prompt. Since I'm doing Windows, I am using command prompt. And then cd target directory cls. Now docker is in, once you docker installed, see we can see docker commands is executed, like docker build dot current directory -t, and then image name you can give any name like cloud 4 academy consumer, like that we can give. Enter it, it will start building the image. See, it's building the microservice, it is building the image. That microservice, consumer microservice, we are converting to image, is creating the image. It will take some time because it has to load, and but it's, see, so based on the image size, code base size, right? This is small code, so it will be done in a couple of seconds. Yeah, image is created. If you want to see the image, we can see images, Docker images, Docker images. See, these are the images I already created. So this is the latest image. This image actually is created. So you can copy this image. This is the image name, consumer name. If you Docker image means you list out all the images, right? So now I'm going to create. I'm going to tag this image. I'm going to tag Docker tag and image ID. Image ID, what is that? This is image ID. Copy this image ID and then what is the name of the image? What is the name of the image? This is the name of the image. Coming here, and then you have to give name is like, first you have to give the Docker user ID. You can see it's a Docker user ID slash, and then image name consumer colon. You can give any name. Since we give correct image ID, should be correct image ID. You have to give version 1. I'm giving version 1, right? I'm enter. Now tag it, right? Once tag it, we have to push this image into the repository. I mean into this Docker hub. So for that, what you have to do is push and then same name and enter it. Enter it. So now image is pushing to the Docker hub, right? Docker hub. So it's pushing the image now. It takes some time because it has to, Docker image is pushed now. So it will come some message. It will come saying Docker hub image is pushed, right? So if I go to Docker hub, we can refresh the Docker hub. We can see that. Let's say we can go to, you can see the home page, repository, where we can see this is the image. You can see the Cloud Academy -consumer. Just now it's pushed. It's a public image. If I click this, you can see which version it is tagged, V1 version. If I click version, this is a complete image name. You can see the /Cloud Academy consumer :V1. This is the name we have to give while running the image or wherever we want. Guys, now we have built the image. So I can see this image. This is the image actually. So we are going to launch this image as a container in Docker, and then we are running the application, right? So I have already console is open in the target directory where our Docker file is hosted, but you can run anywhere. We can run any other directory. We can run the Docker command. So we can go to like Docker publish. This is the command I'm using. So copy it here. Docker run -- publish 80 port number. We can give 8081, and here also like 8081, and then image name we can give, this is image name. Copy and give the image name. So I'm just going to, so this is you can say this is a Docker ID. You have to give Docker ID and then image name and then version number, right? So that is easy to track that. But Docker ID should be there actually before that. See Docker ID Cloud Academy V1:V1. Now I'm running this. Now Docker is starting that. See, starting the Springboot application. So it's providing the runtime environment where we are running our consumer microservice, right? It started 8081. Now if I go here and check this application, close this browser, I'm just running http://8081:localhost 8081 home. See, now application is running. So producer microservice is not started. There is a circuit breaker is on and the error message is coming, right? So others are fine. Now consumer microservice is up. If you want to see whether container is launched or not, we can run anywhere Docker ps. See, now the container is launched. This is a container ID. This is a image name, and 49 seconds back it was launched actually, right? So we can see that. If once we let's say I stop this, it will automatically container will be stopped. So I'm going here. If I check here again launching, see container is locked. If you want to launch again, you can run the same command again. We can go here, run publish, and then let's say I want to debug the logs or I want to get into the container. What we need to do is we need to run this command docker exe. Like we have to go here inside docker exe and container ID. Container ID, what is that? Container ID is, this is a container ID. Sorry, before the this is a container ID. Now I think different container ID. Anyway, we will see that. Yes, different container ID will be created. Now search. I'm going here exe, and then container ID is this. I'm just copying, giving that. I'm entering. See, now it's getting into that, right? ls. See, these are the directory. We can see all the directory structure. We can getting into that, and we can see the logs and setting the environment variable. Multiple things we can do, right? So if I want to exit this directory structure, we can exit it, right? So this is how we have to get into the particular container and see the logs and everything we can do, right? Now we are we are creating the image, and then we are launching the containers and we are running our application, right? We have done it, right? So this is how we have to do. So what we did is, high level, we have consumer microservice we created, and then we created a jar file using Maven, and then we created a Docker file using Docker file. After creating the Docker file, we updated the Docker commands, and then mapping the jar, we updated whatever jar we have created here, right? We updated in it, and then we are hosting that Docker file under the target directory, and then we went to this here, and then we build the image, and then tagging the image name, and then pushing to Docker Hub registry, and then we are running the image, right? And we are running the application. This is what we have done it now. So now we are we are going to discuss about logging tracing, how we can trace the microservices log. Let's say microservice, consumer microservice is calling producer, and producer is calling some other microservice, right? But if you want to track that exactly which microservice is called, which request is called, and which request is sent, so we want to know that. We want to know which microservices we have called. So there is called a tracing ID. Tracing ID means it's a request ID which is unique for every request and response. It's a unique ID, and that is tracking, like let's say microservice 1A and microservice B, microservice C. The complete flow, the request, the tracing ID will be same, right? It's a unique ID, it will be same. And span ID is nothing but refer the flow. Let's say add operation or delete operation or update operation. So that's referring the operation. So whenever we are calling the microservice log tracing, whenever we want to do any debugging, we want to debug that, we want to see the tracing ID, and based on that we can check the logs, and what is the response time of the service, and how much time it is taken, the response time, and which request is sent. So all those things, and what is the CPU time, so all those things can be tracked, right? So this is not CPU time, sorry, the response and request data we can capture it, right? And in our before Springboot 3 version, we are using Sloth is creating the trace ID, but now since we are in Springboot 3.2, we can go to micrometer is a log matrix. It will tracing the log, and we can integrate any of the open source tool like Prometheus or Grafana, or any of the so any of the open source or any the monitoring tool, we can integrate with that, and we can get the nice visualization, right? That's what micrometer will do. We can get into that, how to integrate micrometer, right? And Zipkin is a tracing one. We can track the logs, error logs, debug log, and what is the response, how many response we can see, and using the tracing ID we can check the logs here. This is like it's like a Splunk log. If anybody using Splunk log, you can understand that. Like that we can use Zipkin. Zipkin is just all about just adding the configuration is very quick way. Just we can go to the dependencies, and we can see that. And next thing is we can go to so this is when our consumer, the next session, in the next topic is connect. When the consumer migration is calling to producer, we can trace the logs, which logs is tracing, which service is called, everything we can check in Zipkin. So that's why we are going to integrate Zipkin as well, right? So let's get into the demo. Hi guys, I'm going to integrate micrometer. Micrometer, as I said, is a log tracing framework. So I'm just going to integrate micrometer. So using micrometer, when the consumer, let's say consumer microservice is calling to producer, but if it is calling 100 plus calls making from consumer to producer microservice, if there is any error goes, we cannot find out which request we made to producer microservice. And if I want to debug producer microservice, it's very difficult to identify, because we don't have any particular unique ID, right? When you are integrating this micrometer, it will create a unique ID that's called a trace ID, and span ID. Span ID is nothing but refer the flow, but majorly we are seeing the trace ID, right? So how we are integrating, I can show you these 3 dependency. We have to add 4 dependency. Actually that we have already added. So I'm going to integrate this dependency in the consumer microservice, right? So I'm going to add this dependency in consumer microservice. I'm going here. I'm just going to pom.xml. I'm going to pom.xml. In the pom.xml, right? So after resiliency, AOP, I'm adding at last this three dependency. This one is micrometer observation. It will collect the log metrics and then trace like what time the response is called, what is the request, what is the response, so what is around network round trip happen. So all the details it will be collected, right? This micrometer tracing. And then Zipkin report Brave. This will be sending to Zipkin tracing. Zipkin tracing. This will be sent. So this will be sending the log tracing to Zipkin. Zipkin is a tracing and it's a monitoring tool, right? If you are the micrometer will collect all the metrics and send it to Zipkin via this dependency, right? So and then actuator we have already placed, so that's why I have not copied. So these are the dependencies required to integrate the micrometer. And then the second one is we need to add this in the property file. So all these two logs, two entries required in the obligation.property in consumer. I'm going to consumer microservice. I'm just adding it. Let's say I'm in this give space. See, these two properties are required. So first property is management dot tracing dot sampling dot property probability. It has to tell every action, it has to collect the metrics and send it to Zipkin. That's what here is 1.5, 0.1, 0.2. Based on the action, it has to every seconds or every milliseconds or every action we can configure this. So every action we have to configure this. And logging dot pattern dot level. This is something like how it will format the logs. Like let's say it will show the application name, Springboot, microservice name, and then trace ID and then span ID. It will display like this. It's a very small minor configuration. Once we did this configuration, and same configuration we need to do it in the producer as well. I'm going to producer microservice, resources, application or property. Here also I added. So that producer also we need to see, right, what is happening. So I'm just saying copy the same dependencies, observation micrometer dependencies, and I'm going to pom.xml. I'm adding that. So here the actuator is not there, so we need to add the actuator as well, right? So I'm adding these three dependency, actuator, actuator, Zipkin reporter Brave, and then micrometer bridge Brave and micrometer observation. These are the plugins we have to add it. Now I saved it, right? So now what I'm going to do, now I'm going to Zipkin. Normally what we need to do, we have to download the exe and then we have to install it, right? If a normal way, and then we have to configure. Instead of that, Docker image there is already there. See, this is a Docker image. It is already there. So we are going to run this Docker image, and then Zipkin will be configured. We don't need to do anything. That's all the magic of Docker, right? For that I need to start the Docker, right? So I'm going to start the Docker. I click with the Docker. Docker is started. So let's see, once it's started, the icon will appear here. See, it is appeared. Icon in Docker is starting. It's still in starting mode, it has to be run, right? Now I'm going to add the logs, right? So tracing ID we don't need to add, it will automatically appended in the logs format. I'm just going to add some info message. Let's say home controller. I'm just adding the logs. Logger dot info calling Cloud4 Academy micrometer tracing, log tracing, right? Added. Same thing I'm going to producer, one of the class I'm adding. Any class we can add it, I'm just adding in the controller. Here I'm adding same way. Producer list, because of that I added logger.info micrometer tracing. That's it. Now added. Now I'm going to start the server. First I'm going to start the consumer microservice. Before that, we will launch the Docker image. This Docker container, we will launch that. I think Docker is started. Let's see here. Yeah, Docker is running. Now I'm going to any of the console. I'm going to console run as administrator. So I'm going here. It is there. So I'm going to run the Docker run -p colon or publish anything we can use. Run colon port number, or this is image name. This is a image name. What is that? This is a Docker ID and this is image name. This is a version. Now I'm entering that. It will start the Docker. It will start the Docker image. Now the container is launching. See, Zipkin container is automatically started. We are not configuring anything related to Zipkin, right? We are not installing anything, just launching the Docker image. So this is the IP address they are saying. So we'll go there and check the IP address, what is there inside. I'm entering that. See, Zipkin is launched. Zipkin tool is launched. So this is a monitoring tool. I'm running query. There are no traces are found. Right now, I am going to start the consumer application. First, I am starting consumer application, and then I am going to start the producer application. I'm going to start the producer application. Right. So both application I have started. Microservice, both microservice I have started. Consumer and microservice. If you see the log, see, it is saying microservice name and comma. This is not coming still. So now I'm going to, our consumer is going to call the producer. Is going to call, like, let's say I'm going to call http localhost 8081 is, right? I'm running that. Now service is started. It is displaying the recent product and this feature product, and recent product also it is displaying, right? So consumer is calling to producer, and then it's the consumer is populating these results. Now if you go to logs, so we want to trace the logs. This is a producer microservice log info. See, producer microservice, this is a log format, log info format, microservice name, and this is a trace ID. This is the span ID. So now I'm tracking this span ID. I'm noting I am in the producer microservice. So I'm just noting this ID. This is the ID. Same thing I'm going to consumer microservice. I'm going to consumer microservice. I'm just going to check here. Here also, see, called producer microservice class is saying logging, calling, load tracing, controller. Only thing is, this is important. See, this is a microservice name is consumer, trace ID, and this is span ID. I'm going to copy this trace ID. Now I'm entering. See, this is unique, right? Trace ID, this is unique. So 661 F7. So this is a trace ID. Now I'm going to produce a microservice 6667. Where is that? It's not calling that 6667. Okay, we'll go there. We'll trace the logs. Now I'm clicking run query. See, these many logs are. See, these are the logs are captured. You can see expand all. You can see what is the URL. We can see how much time it is taken. See duration, and show means it will display detail. What is the product image? So it is calling. So what we can do is we can go here, service filter, consumer, expand all, settings. If you go there, you can see last 15 minutes, and you can see that all the how long we need logs we can select that query, and then trace ID. I'm going to give the trace ID. We are in, let's say, consumer microservice. I'm going to copy that trace ID, and I'm giving that trace ID. I'm giving. So I'm entering that. Now for the trace, whatever microservice it is calling. So I'm just taking which is highest, calling this microservice called this product image URL. If method is get, and outcome is success, status, and URL. Like that it will display all the details the microservice URLs. Now I'm going to check. Let's say producer microservice. I'm going to check. Producer microservice. I'm going to check. I'm just calling producer microservice. Yeah, see, producer microservice. What is happening is trace ID is one trace ID for that microservice name, and this URL, microservice URL, 0 seconds, finish, and HTTP URL is fetch category feature. This URL is called success. Outcome is success. This is URI category ID. So this is producer microservice tracing. I'm just displaying the trace IDs. I'm displaying. So this is how it will work. So now I go back. I'm just clicking here. So trace ID I'm copying here, 6688. Producer trace ID. I mean run query. So these are the logs are fired. Still showing consumer. No, I'm just coming producer controller 668 consumer. These are all consumer is called product microservice. So once again I'm entering here. See, only one service which is called product microservice. These are the trace it is displaying here. Right, one trace it is happening, so we can see that. Right, so this is how we have to integrate our micrometer in Springboot 3.2. Right, so consumer. So if you, when you are working the actual flow, then you will understand how we can, this trace ID will be same for all the microservices, like producer microservice and consumer microservice. The trace ID will be same. Only span ID can be changed based on the flow, but this is will be unique. Actually here it is unique, and then this will be same ID will be used across all the microservices. So this unique ID, right? So this IDs are generating. And span ID F7. So here F7 is there. No, F7 is not there. So if I call again, tracing. So now it's a different ID. See, it's a different ID. This microservice. I am in consumer microservice. See, consumer 277. 277. Is ID. So this is what the log tracing will display. This is a warning, we can leave it. Only info we can take. See, these are the logs are generated. Logs, we can display any request or response on top of it, but the format will be like this: consumer, and then trace ID, and then span ID. So this will be displayed like this. So if you go to any of the microservices, see the log, it will show this format. So if you want to trace the log, take this ID, trace ID, go to Zipkin, and then enter this trace ID and enter. It will find which are the services are called. Get home method is called. So that's why it is showing this, right? So this is very simple configuration. So we can trace the logs here. And if you want to run the query, like go back and run query, it will display. That's it, guys. That's it, the demo, we have done it, and let's get into other session. Thank you, guys. We are going to discuss today the Kubernetes. What is Kubernetes? Kubernetes is a container orchestrator which is used to set up the cluster in cloud environment, right? So Kubernetes itself, there is a pod is there, controller is there, scheduler is there, service is there. So these are different kind of work we'll do. Inside the Kubernetes, a pod is launching the container. Inside every container there is one pod will run. So it has the capability of horizontal scaling and vertical scaling. Horizontal scaling means whenever any workload is heavy, then it is launching additional pods. whenever workload is coming down, then it's reduce the pod count. So that kind of horizontal vertical scaling we can do it in Kubernetes will do that. And vertical means it will add additional nodes based on that, right? Let's say we have 3 VMs, so it will split it into multiple nodes, right? Inside the node we can deploy our microservices, and then microservices is launching as a container, as we discussed the earlier session, right? So in Docker, like that is running in Kubernetes, it is running that. When it comes to testing part, right, Kubernetes changes cluster, we cannot test it in our local, we can test it only in cloud environment, but still there is the option to test the changes in Minikube in our local. Minikube is nothing but a single cluster node. There is only one VM and then only one node. So it could be virtual machine. We can use any of the virtual machine, like Docker also providing the virtual machine. We can test the Minikube installation and everything. I will getting into the session. We will see that, right? And then building the Docker image for consumer and producers, and then deploy the consumer and producer microservice into Minikube. So normally, if you want to deploy any consumer, any microservice, you need to create a deployment script and then service script. Deployment is nothing but is to deploy the script into that, and like that consumer is whenever we need to deploy, we need microservice, we need to create a deployment script and then service script, both has to be created. So deployment is going to deploy it into Kubernetes, and service disk is going to service XML script is going to connect the microservice, whether it could be a external load balancer, or it could be node port, or it could be a cluster IP. So there are multiple services are there in Kubernetes. We can get into that, we can discuss on that in the further Kubernetes session on that, okay? And then service discovery, we can call the consumer microservice to producer microservice without using localhost. It will use the service name, right? In Kubernetes, service discovery, using service discovery, because one consumer microservice, when you are deploying to pod, we can have multiple pods for a single container. There are 5 pods and 5 different containers with the same image, right? You can deploy that. So, but there, whenever we are launching additional instances for the microservice, the IP address will change dynamically, right? That's the reason we are using Kubernetes service discovery. That will taken care. So we don't need to hard code anything like IP address or localhost. You can just name the service name, so it will automatically work. We will get into that covering this session, how we can do the code changes and how we are deploying the scripts on the in Minikube, right? And then testing the consumer and producer microservice, right? Thank you guys. Let us get into the session. Hi guys, we will get into the session. So how we can integrate the Kubernetes service discovery, right? So what are the changes, code changes we need to do high level? We look into it. Okay, we look into it. I'm just going to the code changes first. First we will need to unnot the enable discovery client. So first let us add a pom.xml. So this is a pom.xml. We have to add it, pom.xml. We have to add that pom.xml. We go here and add the consumer pom.xml. So this is a pom.xml, Spring Cloud Starter Kubernetes Fabricate. So this one we need to add it, and then we have to go here and we have to add enable discovery client in the Springboot class, consumer class. So Springboot application, right, where we have to add this enable discovery client, and then we have to go here, add this auto where the service discovery, we are injecting that, right? This instance we need to inject the service layer where we are calling our producer microservice, right? So we just importing this package, and then we can also edit that. And then see, currently this method, what it will know, it will call the producer microservice, which is localhost 8083 is a producer microservice, but it should not be the case when you are using the Kubernetes service discovery. Earlier version we are using Eureka discovery, but Spring 3 and 3.2 and above we are using Kubernetes discovery, right? So when you are using Kubernetes service discovery, we have to write this code. I have already written that, so I'll copy this code. So we can remove this code, and I will copy this and return null here. So if it's something, yeah. First we are first what we will do, we will get all the service list from Kubernetes. We will get all the services from Kubernetes. So this will return the list of services like producer microservice name, and then the discovery client is returning the service list from Kubernetes cluster, and then it will return the producer service. We will check that whether the producer service is there or not. If it is there, then we have to add the, instead of localhost or IP address, we have to add the producer service and :8083 we have to add, right? 8083 is a producer IP address, and then fetch using category and category ID. This is a final URL which is used to call the producer microservice, and then HTTP method, REST template we are instantiating, and then HTTP method. Here headers, if you see the headers, you have to add the header method. You have to add the header. So the header method I'm just adding here, right? Header method, adding header. So I'm just going here, importing the headers, and then media types, and then HTTP entity. So these are the headers, we need to add it, right? We need to add that. Now headers are added, right? So this is the code changes we need to do. We have to just fetch discovery client, we have to instantiate, I mean injecting this, and then this will fetch all the current services which are running in Kubernetes cluster. Let's say producer microservice is available or not. If it is available, we will do the, instead of writing the localhost, we are writing producer service and :8083 is a producer microservice port number, and then fetch using categories as a URL, and then REST template instantiating, and then we are calling the microservice, right? And this is a header, we have to add it. So these are the code changes we need to do as part of the Kubernetes service discovery, and there are three properties we need to use. There are three properties we need to use. One is this one. These properties we need to use. Go here and application.property. We have to adding in both consumer and producer microservice. Both application.property we need to add this, right? And then finally we have to add this dependency in producer microservice as well. You have to go to producer microservice. Go to producer microservice. There also we have to add that. Fabric is already added, so we can leave it. And consumer also we have added, right? We have added. See this dependency we have added. We have to add this dependency, right? So once we have done it, then what we will do is I have written the scripts for Kubernetes scripts for running these scripts. These are YAML files which will be executing in the Minikube cluster, right? It's basically this will be running in the Kubernetes cluster, but I'm going to run in the Minikube cluster, right? So first consumer means consumer microservice. We have to deploy that. We have to write this script. And producer workload means producer microservice. To deploy that, we have to write producer microservice. And then role binding. These are the discovery role binding service. These are the roles which needs to be deployed, because whenever a producer microservice is calling to consumer or consumer is calling to producer, there has to be access. We have to permission, access, role has to be created in Kubernetes cluster. So when you are getting into a Kubernetes session, I will elaborate that. Okay. So now we are going to check all these scripts. What will do? First, consumer microservice. This consumer kind is a deployment which is used to deploy the microservice, consumer microservice, and this app is a version number. And replicas. Replica is 1 or 2 or 3. There should be minimum. Replica should be 1, means there is always one producer microservice service will be running, right? Irrespective of microservice is down or not, always one microservice will be up. Pod is up, right? This is one pod, right? One pod will be launching, one container minimum it will be running. And then consumer microservice here also, and here the image name we have to give. Image name we can give any name, but I'm just once we build the image, we have to give the correct image name. So microservice we are not built still, so we can leave it just for now. And container port 8081 support number. And here /dash means another service also we can write within the same YAML scripts. If you use /dash, because both are related, right? So service supposed to be a separate YAML, but since it's both are related, I'm writing in the same script, like app version number, and then kind service, and then consumer service, and then service, and 8081, and TCP load balancer. This consumer microservice basically we are exposing in the browser, right? It's accessing the UI and showing everything. That is exposing to the outside world. That's the reason it's a load balancer type. If you see the producer microservice, same changes we have to do. Version number, deployment, producer microservice, replica, or 2 or 3 or 4 based on our use cases we can add it. Since it's a testing environment, I added only one replica. So always run minimum one instance, right? That's the reason I'm adding replica 1. And producer service name. Here also image name of the producer microservice. Once we created the image, then we can configure that image name here, right? And container port is 8083. Here also app version service, producer service, and ports 8083. And type is cluster IP. Cluster IP is within the microservice cluster. Within the cluster, it will communicate one microservice to another microservice. It will not expose to the outside world, because producer microservice we are not exposing to outside the world. Within the, because consumer only is going to call this microservice. This microservice is not calling from the UI or in the browser, right? So that's the reason we are, this is a cluster IP. And another port is node port. Node port service means if you want to web server, we can expose as a node port. You can access through the browser, right? So that we can add it. So there are multiple services. There are 3 services: node port, cluster IP, and load balancer. So I will elaborate when we are discussing on the Kubernetes session, right? So, and then role binding. This is a role, and you can check Google it, what is the role and role binding in Kubernetes. It will elaborate that. So we have to add this role binding and role scripts. And here service account we have to add service account, and then here also role has to be added. So this script needs to be executed in the Minikube, right? Okay, now so these scripts has to be executed in the Minikube cluster. So before that, we will build a jar. We will build a microservice. We are going to consume a microservice, and then we are creating a jar, and then build a image and pushing to Docker Hub, right? So we are going to do that first. So what I'm doing is I'm going to pom.xml consumer, right click, and I'm going to run as maven build, and here I'm giving package. I'm giving package. I given the package, right? So if I give package, what it will know, it will run the compiling and build the jar file, right? It will create a jar. Now jar is created, right? Now jar is created. If you go here, jar will be there. Target, refresh, and see consumer -0.0.1. Already we have the Docker file we have already created in the last session, right? Same configuration we can keep, like Eclipse, JDK Alpine, and temp, and this is a jar file. This is a jar file name. We can give everything same configuration Docker file, and we will go to this location and then build a Docker image. So first I'm going to the property file. I'm going to this location. So because the Docker file is hosted in here, this path, that's the reason I'm going here. I'm going to run the command prompt, run as administrator. I'm going, and then I'm just going cd running, and I'm going to run a Docker. Here Docker is running. If you see right click, see Docker is running, right? So Docker build space dot -t. Image name you can give any name, like consumer cloud 4 academy, consumer cloud 4 academy. I'm giving, I entering that. Now image is building that. See, running that. It's running. Image is building. It takes couple of seconds, and then it will build the image. Image is build. Now we will list the image. Go to Docker images. You will get the image ID. See, if you see the first, this is a consumer cloud ID, right? This is image, the image ID. This, copy this image ID and go here, tag it. We need to tag this image. Tag image ID and the name of the image. What is the name of the image? Copy here, go here, and then enter. Now tag it consumer image. So we have to give the, like, you can see this is a Docker ID, right? Docker ID / image name : version, let's say version 2 will go, version 2, right? Version 2. Now tag it, right? Tagged CLS. Now we are going to push this image to the Docker Hub. I am not testing this because it's already tested, so we can directly test in Minikube. Push you can see I'm just pushing this image. Now this image is pushing to Docker Hub. Yeah, it's pushing. So I'll open the browser, so we'll check the Docker Hub, it is pushed or not, this image, right? So now, sorry, pushing. So still this image is pushing. It will take a couple of seconds, and then it will push that image. Go here, Docker Hub login. So it will log in that. Still Docker image is pushing to registry. It is taking some time. So sign in. Going to sign in, and then yeah, image is pushed, I think. Let's see. Yeah, image is pushed. Image name is version 2 Consumer Cloud Academy, Cloud 4 Academy, right? We are going here, refreshing. So the name of the image is, this is image, Consumer Cloud 4 Academy. Just 1 minute ago it was deployed. So going here, how many versions are there? Only one version, v2. Click the version and copy this image, and then we go to the deployment script, consumer, right? This is a consumer deployment script. We have to add this. Remove this image. We have to put our newly built constructed image name. This is image. You can see to consumer Cloud 4 Academy v2. Like that, we need to build a producer microservice. Go to producer microservice, and then go to the pom.xml. Right click, build, and then package. Run a package. Now it will execute it will create a jar here. It will create a jar. Yeah, it is running that. Still is going. Once it is running, yeah, it's running that. Yeah, I think it's downloading. Yeah, build success. Now the jar will be created. Right? Now the jar will be created. So we will go here and then target. Go here, target. So here this is a jar is constructed. So this jar it is constructed. So I copy the same Docker file here as well, producer microservice as well, but the name we have to give this name. We have to give this jar name, producer microservice jar 1.1. I'm opening this Docker file. So currently it is opening for, it is there a consumer microservice jar name, right? You have to give this jar name. That's it. Given the jar name, Cloud 4 Academy producer, like producer test jar. So here also you can rename it. That's it. Now we can go to this this folder, and we will execute our we will build a image now, right? Now we can go here, cd /cd cls cd this image path. Right now Docker, because Docker file is hosted in this location, that's why we are giving like this. Docker current directory build -t, and image name is extra piece I given, producer hyphen Cloud 4 Academy only we can give. Enter it. Now image is building. In couple of seconds it will build the image. We are tagging the image before deploying it, before pushing to the registry. Now the image is created. Now I'm going to images list, checking images. So this is the image name, actually the producer microservice, this is the image ID. So I'm going to tag it, Docker tag image ID and then image name. What is the image name? Producer microservice. And here you have to give, you can say to say Docker ID / image name and then colon v2 just adding this. Actually we'll give this v2 and then I'm just pushing this image, entering.
Yeah, I'm pushing this image. I tagged it, so I'm going to push this image. You can see the Docker push and the centering push. Now pushing this image with the version 2. It will take some time actually. I think it will couple of seconds it will be done. This is a small microservice, so it will be done. Yeah, now it's done, I guess. So I'm going to refresh the page. I think still it's running. I'm going to, is it deployed? Pushed? Yeah, it's pushed. Now I'm going to Docker Hub. I'm refreshing repository. So now this microservice build producer VSN is v2. Click that and it will complete URL path of the image. Go here and now go to producer microservice. This is a producer microservice. Remove this image, existing image path, image name, and add this new image name which was constructed, which was built now, just now. Given this, right? Image name is given. Now we are good with we build a microservice and then created a jar and then created an image using the jar. And then that once we created the image, then we are giving the image name as the producer and consumer. Now we are going to start the Minikube and then running these clusters. So I'm going to execute the scripts. First I'm going to launch the Minikube. Command prompt. So sorry, already Minikube, I think already command prompt is started. So which is already in this folder only. I'm going to complete course Kubernetes cluster where I'll post all these scripts. See all these scripts. I'm going to first we have to start the Minikube. Minikube has to be installed. I'm just going to the steps how to install Minikube. So just go here, browser, install Minikube in Windows. Install Minikube Windows on Windows 10. So if you go here, this will tell how to install Minikube. You go to Kubernetes, see Minikube start, we have to execute installation. Windows means Windows, and these are the steps needs to be followed. PowerShell, script, stay layer, cluster. So all these steps needs to be followed to create a Minikube, right? Install a Minikube, sorry. Once we install a Minikube, then we can open a Minikube and then it will start the Minikube and we can do that, right? So this is what we will do. So I'm just going to start the Minikube, right? Now I'm going to the console. Command prompt is already opened. So I'm going to, because Minikube I have already installed, right? Minikube I have already installed. So that's the reason I'm going to Minikube. Any folder, we can go to any folder because Minikube can be started anywhere. Minikube start means it will start the cluster. See, it is starting that. Minikube is starting. It will take some time. It will take a couple of seconds to start the Minikube. It will set up the cluster and it will start that. We can wait and see it's loading and then it will be done. So it will take time. Then let us get it. Once Minikube is started, then we will do then we will execute all the scripts in the cluster, Minikube cluster, and then try running the consumer microservice. First we will deploy the consumer microservice. Now I think Minikube is started. So if we check Minikube status, it will be Minikube status. If I run this, I think Minikube is started. See, kubelet is running and app server is running. Kubeconfig is configured. So now Minikube cluster setup is done in single cluster node in Minikube, right? So prior to that, I just wanted to show this. I have used 3.1.0 version because I used Kubernetes service discovery 3.0.3 version. So this dependency, that's why this dependency. So I fixed this and I rebuilt the jar and then recreated the image and I just updated in the YAML file in Kubernetes script YAML file. I updated. Here I have updated. I can show that where I updated the script producer workload and consumer workload. Both workload I have updated the image name. Here we have updated. Here also we have updated the image name and then path I have modified. Actually here brand URLs is supposed to be local. It was localhost. Now I changed it to the IP address. But if you see in production, it should be www.cloud4.com. Like this, some domain name should be there. But anyhow, since you said I just tested Minikube, I used IP number because this is a standard IP. So I'm just going to start Minikube tunnel also. Minikube tunnel is used to external IP it will give. I mean load balancer can access that. That's a Minikube tunnel we need to start always. Okay. So now I have just done it. I'm going to start. There are a couple of scripts I am going to execute, which I discussed, right? One is role binding, service account, and Cooper discovery role.yaml. So I am going to run one by one. First I will execute this one. Kubectl is nothing but a client like Kubectl is a Kubernetes client which is used to connect the Kubernetes cluster. So using this we are running all the Kubernetes commands, right? Kubectl command is using that we are running all the kubelet commands, Kubernetes commands, which is connecting to Kubernetes cluster, right? Apply -f means we are deploying this particular script, role binding script. We are deploying that. Now it's deployed. There are no issues. I'm running CLS there, and another one is kubectl apply -f, and then I'm running service account I am running. So this is also created. If there is any error while running the script, it will show the error message. Now script is fine, that's why there is not showing any error message. Now last one is Kubernetes discovery role. I'm just running Kubernetes discovery role, right? So I'm creating everything. Now I'm going to run a consumer microservice. I'm going to deploy a consumer microservices. Consumer microservice, this is a consumer microservice. So basically this file I am going to deploy consumer microservice. This microservice I am going to, this script I am going to deploy that, right? So I'm just running. Yeah, it's deployed. There are no error. So if I want to check, we can check kubectl get pod, means it will, you can display pod if it is running. So pod is running. This means there are no error, right? It's pod. If you want to see a service name, means get svc. So this is a service. The service part name is this service name is consumer, right? Consumer service. This is a service name. If I want to describe the svc, we can describe the svc. Describe svc. So this will give the detail, all the details of Kubernetes services. Describe svc. If I give particular service name, we can give like kubectl get svc, right? Get svc service details. We can give describe svc and then consumer svc. If I see consumer svc, it will give only consumer service details. See, load balancer increases 170.0.1. so this is IP address it is exposing. If you can access this IP address, it will work. Endpoints is created 172.0.0.81. so if our service is deployed properly, then endpoints your IP should be created, and load balancer is this needs to be created. So if it is created, means our microservice is deployed properly, right? So if I want to check deployment, there is another service called deployment. Command is deployment. If there is, we can see only one deployment. Consumer we are deployed, right? So now we are going to deploy other service, producer microservice. So if you want to deploy kubectl apply -f producer.yaml. so this is also deployed. Now if you want to check kubectl get pod, you can see now two services are running. Consumer microservices are running, producer also running. If you want to log, you can check kubectl logs and then see the copy this consumer pod ID. If you give this, it will show the log. See, there are no error. Server is started. Like that, if you want to check kubectl producer microservice, you can check producer microservice. Copy, running this. See, there are no errors. So no service are called. Now I'm going to call the service, right? So we are going to call the consumer microservice first. So to do that, what you can do is kubectl get svc. So now I given capital svc. So this will give the svc, right? So this is svc. Where is svc? Yeah, consumer svc. Copy that kubectl. So kubectl describe svc and svc name.
So now this is the IP address, endpoints, this is the IP address, load balancer IP, we can run this one, or this one you can run. Let's see this will work or not. HTTP colon this one slash home. I'm running, whether we will see this, it will work or not. I don't think so this will not work. We have to run this one. We have to give this IP, load balancer IP. Load balancer IP we have to give. So it's not working. So we'll give this way, like HTTP colon this one colon 8081 slash home. So if I give this, it will run that. See, it's running. Now our consumer service is running in the Kubernetes cluster, right? It's deployed successfully, and it is calling the producer microservice and then returning the results without using localhost, local IP, right, or any IP address, using the service name. See, you can check this client service. This is the URL. See, producer service colon 8083. You can check the final URL here. We'll go the logs and I will show you the logs. Get pod, get PO, and then logs, and then producer. So we'll see whether producer is called or not on the log. See, this is called producer list, called feature. These are the services called producer tracing, micrometer, everything is displayed, right? So if you want to final URL, you can check here final URL. Final URL. So microservice is called, right? So this is called. Now I'm going to open the consumer log, consumer microservice log. Now kubectl logs. So I'm going to consumer logs. Now I'm going to kubectl logs, consumer microservice logs. I'm opening that, right? Kubectl logs consumer. See, we can see the final URL. What is the final URL here? We can see final URL. What is the final URL? Final URL, right? We display the URL, right? So which URL is generating, we can see that. So this is the final URL. See, this is the final URL. What is the final URL? We can check here. These are logs we printed, right? So this is the URL to call the producer microservice, right? So this is the way. See, this is the URL. See, if we check this, this is the URL. HTTP colon producer service 8083 fetch product using category recent product. If we call this in Postman, you can check this. This is the URL. Postman, you can check this. So this is the URL. So this is the way we have to call our. This is what the Kubernetes service discovery will work. So we are not hard coding any IP address or any local host. We are using the service names, Kubernetes service name, and then we are calling this microservice. So this is how the Kubernetes service discovery will achieve the load balancing. We can achieve the load balancing, fault tolerance, and so everything we can achieve through the Kubernetes discovery, right? Service discovery. So I have opened that in Postman. I have opened the same URL. You can run execute here also. This is a post method, get method. It will give the, see, anyhow it's not working in Postman. That's fine. External URL you cannot use that because this is only cluster, right? This if you see this service, this is within the. If you see this service, this is a cluster within the cluster. So only consumer microservice can expose it outside the world, the load balancer, because it's a load balancer type. This is cluster because one microservice is called within the cluster only. This will be called. This will not expose the outside world. So this is how we need to connect the. We need to use the Kubernetes service discovery. So we have seen that. And for more details, step by step configuration, we have given in our Cloud Academy, Cloud 4 Academy LinkedIn page. You can visit our Cloud 4 Academy LinkedIn page. You can see how we have integrated. You can go to cloud4academy.com, and the bottom of the page, if you see this page, Cloud 4 Academy, cloud4academy.com. See here, you can check our LinkedIn page. You can click and you can see step by step configuration of Kubernetes service discovery. So you can check that. Okay. So now this is how we need to configure, and so we have, see, this is the producer is returning the results. So cluster, we are running this application, right? Anyhow, we have done our session. Thank you for listening, and let us get into next session, and thank you guys.